Welcome back to this video lecture series on data structure and algorithms. So today we'll be seeing on the construction of binary tree from its pre-order and in-order traversal. So suppose the binary tree to be constructed is like this, where the root node is the C. It has two child B and E, and again B has a left child A and E has two child D and F. So if we do a in order traversal on this binary, we get the sequence A, B, C, D, E, F. And if we do a pre-ordered traversal on this binary tree, we get a sequence like C, B, A, E, D, F. So two things to observe from this traversals is that the leftmost node in the sequence of the pre-ordered traversal is always the root node of the binary tree, and the nodes lying left to that root node in order sequence belong to the left subtree, and the ones lying right to the node belong to the right subtree. So now when we'll be doing the program for tree construction from the in-order and pre-order traversal, we'll have to keep in mind this particular algorithm. So first what we need to do is pick an element from the pre-order traversal sequence, then we increment the pre-order index of the sequence to pick the next element in the next recursive call. The next step is to create a new tree node with the value picked from the pre-order sequence. In the next step, we find the index of that node picked up from the pre-order sequence in the in-order sequence. Then we call the function for all the elements before the index and make it as the left subtree of the node. And again we call a function for all the elements after the index and make it as the right subtree of the node. So let's now jump onto the programming part and see how we can implement it. So I have opened my IDE and I have already typed down these lines of codes. So this is the tree that is to be constructed here, and I have taken the in-order and pre-order traversals of this tree in two different arrays. I've also previously typed down these two functions, the new node construction function and the in-order traversal function of the binary tree. So I'll start from here in the main function. So here first I need the length of the sequence of the traversal, so I'll do this size of n by size of. So by doing this we get the length of the array, and then we make a root node of the tree because we'll be needing that for the in-order traversal purpose. So here we will actually operate the function construct tree, and here the arguments will be the two arrays starting index 0 and the end index, that is len minus 1. I'll keep it in a pair of parentheses. Right. So after we are done with the function, we'll simply check whether the tree construction was successful or not. So I'll print out this message: the in order traversal is. I'll again call the already defined function in order, and lastly I'll just print down a new line. So the only task is we need to define this construction tree function. So the return type will be struct node star. So here I'll leave the names as they are. Okay, so this will be, let's say, start, and this, let's say, end. So first what we're going to do is going to take this variable static end tree index 0, Then we'll check for this condition. If start is greater than end, then we'll simply return null. Now after that we'll make a node, so struct node star node. So here we'll be using the new node function, and the argument will be plus plus. Now again we'll check for this condition. If start matches with end, then we'll simply return the node. Otherwise what I'm going to do is we'll be searching for this index of this particular node in the pre-order sequence. For that we'll be needing a function called search. Here the arguments will be the in order, then the start index, then the end, and lastly index of what? And lastly the node data. So I'll first define this function before moving forward with this construct tree function. The return type will be int. Here this will be a type of array. I'll keep it just like they are. This will be changed to so here again I'll take this for I is equal to start I less than end I plus plus. In this array here, if I is equal to key, then we'll simply say return the index. So after we get the index here, we'll simply do this thing, that is node left will call this function again recursively with few of the arguments and a bit changed. So this is the function here. I'll pass both of these character arrays. Now the start index will be as it was, but the end index will be the index -1. Right, and the same thing almost is to be done for the node right. So this will be right. Instead of start, it will be having index +1, and instead of index -1, this will be having simply end. So this is the thing. We have already done this part also. So now let's run this program and see how it works. So here is the output, and we can see that the in order traversal matches with the in order array we took. So this was done properly. This is how you can construct a binary tree from its pre-order and in order traversals given. Thank you for watching this video and staying with us. See you next time.